All right, here's our second installment of our 6.2 lessons. In our first video, we talked about linear transformations of random variables. Now we're going to talk about combining random variables. Now this can be a little bit tricky, so pay close attention. Just like in the last video, there are going to be a couple examples where the problems are from another location. I don't have them on your note sheet, so if you want to take extra notes, feel free to, or just follow along. Now, before we can combine random variables, a determination about the independence of each variable from the other must be made. Probability models often assume independence when the random variables describe outcomes that appear unrelated to each other. So you should always ask yourself whether the assumption of independence seems reasonable or not. Now, if S is a random variable that is the sum of two other random variables, then to find the mean of the sum of those two random variables, you would simply add the two separate means together. Okay? Now, if D represents a random variable that is the difference of two other random variables, then the mean of those differences is just the difference of each of the means. Okay? So, if you want to find the variance, this is different, of the sum or the difference of two other independent random variables, then the variance of either the sum or the difference is going to be the sum of the variances of the two separate random variables. Because think, when you're combining things, whether through subtraction or addition, it's getting more variable. Even if you're subtracting, the variability is increasing, not decreasing. So that's why that one's going to be an addition no matter what. So even if you're subtracting two random variables, the variance or the standard deviation is going to increase. Now, notice how we're being very particular and we're saying we have to use the variance. You cannot do this with standard deviations. It does not work. The mathematics do not work out when you try to do it that way. If you want to see for yourself, go ahead and try. It doesn't work. So let's talk about it. Let's let D represent the number of passengers on a randomly selected Delta flight to Atlanta. And let A represent the number of passengers on a randomly selected trip American Airlines flight to Atlanta. So it's two different flights to Atlanta, one Delta, one American Airlines. And we want to have T be the sum of those two, so the number of passengers on both of them together. So we have our two probability models. Here's for D and here's for A. If you wanted to actually do the math, go ahead, but you can just take my word for it that the mean of U sub D is 76.75. Standard deviation of sigma sub D is 1.0897. And then the mean for the Atlanta is 76.1. Standard deviation for the Atlanta is about 0.943. Okay. Now, combining for mean, how many total passengers fly to Atlanta on a randomly selected day? So between the Delta and the American airline. So if these are their two separate means, to find their mean together, you would just add them. Okay? We would just add them together. So for any two random variables, then the expected value is just the sum of those two means. Okay, so in general, the mean of the sum of several random variables is the sum of their means. So this works for more than just two, right? If you have 3 or 4 or 5 or 12, you would just add them all together. Or subtract if it was a subtraction problem. Now, for variance, how much variability is there in the total number of passengers who fly to Atlanta on a randomly selected day? So we need to find the combined variance. So we can't do it with the standard deviations. So we need to square those numbers, right? Because standard deviation is the square root, so variance you have to square it. So then once you square them, you add it together, and that will give you your total variance. And then you would need to square root that to get the standard deviation. Okay? All right, now if you're subtracting, okay, we've talked about this. You would just subtract it. Now, in general, the mean of the difference is the difference of their means. And the order is important here, right? Because subtraction is not commutative, so you can't just subtract in any order you want. So you have to make sure you're subtracting in the proper order as determined by the problem. Same thing for variance. But again, even though you're subtracting, you still need to add, right? You still need to find the addition of your two variances or more if there's more than two random variables. Now, this topic was on a 2013 Frappy question right at FRQ. So they do pop up on the free response questions. So calculating your probabilities when you're combining random variables. If a random variable is normally distributed, we can use its mean and standard deviation to compute the probabilities. Important, if any sum or difference of independent normal random variables is also going to be normally distributed. So that's good. So if you start with A and B and you're trying to find C and you're combining them, C will be normally distributed if A and B also were. Okay, so here's an example. This is an adaptation from your textbook. Mrs. Miller likes between 8.5 and 9 grams of sugar in her hot tea. Suppose the amount of sugar in a randomly selected packet follows a normal distribution, which is important, with a mean of 2.17 grams and standard deviation of 0.08 grams. If Mrs. Miller selects 4 packets at random, what is the probability her iced coffee will taste right? So here's our state and our plan. We're going to let X represent the amount of sugar in a randomly selected packet. So then we're going to have T be the combination of those 4, right? We want to find the probability that it's between 8.5 and 9. So let's do our combined mean. So where are we getting these numbers? So backtrack a little bit. If each packet has a mean of 2.17, standard deviation of 0.08, and I have 4 packets, so that's why I have 4 means being added together. So, oh gosh, the average of 8 should be about 8.68, or excuse me, average of 4. And then the variances, so remember you have to square your standard deviations and then add them together. And then you would square root that to get that standard deviation. Now these are the numbers that we're going to do and use to calculate the probability. Because we can't just use for one packet, we can't just use 2.17 and 0.08. I need to use the combined for 8.68 and 0.0256. Or excuse me, 0.16, because I had to square root it. So here's my lower bound, here's my upper bound, here's the mean of my combined random variables, and here's the standard deviation of my combined random variables. So I get that there is an 84.7% chance that my tea will taste right. Not bad. I'll take those chances. Now, yes, you can use your calculator. It is fine. But remember to recalculate the combined mean and standard deviation before you use the calculator. That is the important part. And you do have to show that work on your paper. All right, another problem. The diameter C of a randomly selected large drink cup at a fast food restaurant follows a normal distribution with a mean of 3.96 inches and a standard deviation of 0.01 inches. The diameter L of a randomly selected large lid at this restaurant follows a normal distribution, mean of 3.9 inches and a standard deviation of 0.2 inches. For a lid to fit on the cup, the value of L has to be bigger than the value of C, but not by more than 0.06 inches. What is the probability that it will fit on a randomly chosen large drink cup? What a fun problem. So what are we going to do? Let's define the random variable D, our difference, to be the difference between L and C. So the difference between the lid and the diameter. The diameter, or excuse me, the diameter of the lid versus the diameter of the cup. Okay, our goal is to find that it's between 0 and 0.06, right? Because it can't be more than a difference of 0.06. So our combined differences, to find our mean, we subtract the diameter of the lid minus the diameter of the cup. Again, they're means. So the difference mean should be about 0.02. Combine variances, and then you square root it to get a standard deviation of 0.0224. So we do our normal CDF between 0 and 0.06, mean, combined mean of 0.2, combined standard deviation of 0.0224, and we get 0.7776. So we predict that the lids will fit properly 77.76% of the time. This means that the lids will not fit properly more than 22% of the time, which is an annoying fact. True life, y'all. True life. All right, one more example, I think. Mrs. Daniel and Mrs. Cooper bowl every Tuesday night. Over the past few years, Mrs. Daniel's scores have been approximately normally distributed with a mean of 212 and a standard deviation of 31. During the same period, Mrs. Cooper's scores have also been approximately normally distributed, with a mean of 230 and a standard deviation of 40. Assuming their scores are independent, what is the probability that Mrs. Daniel scores higher than Mrs. Cooper on a randomly selected Tuesday night? So we're going to be combining. How, though? How are we going to be combining? We're going to do it through subtraction. Okay? We're going to be subtracting Mrs. Cooper minus Mrs. Daniel, because we want to know what's the probability that Mrs. Daniel scores higher than Mrs. Cooper. And then we'll see how that looks in our probability. So we combine our means through subtraction, combine our variances, and then square root to get the standard deviations. Here's a sketch of our normal distribution, right? And we are doing the 4-step process here, guys. Like that hasn't gone away. Then do our math. We want to find the chance that it's less than this. So there is a 36.1% chance that Mrs. Daniel will score higher than Mrs. Cooper on any given night. All right, examples for you to try. You have these in your notes. If you pause this video, I want you to try to work it out. The answers for this, if you look in the PowerPoint, it's in the notes section, but it's also printed out on our class page. There's a copy of all of the filled in notes there. So you can see that. And then same thing for this example. Again, answers in the notes of the PowerPoint if that's where you choose to go, and then the work is in the document on the class page. Okay? This is a confusing topic because it's not always super intuitive, and it is combining a lot. It's putting together a lot of concepts that we've talked about this year. So make sure you spend some good time doing these 2 examples, and we will review in our next class. Thanks, guys.